11-6, systems of equations. I can solve systems of equations.
Great. A system of equations, first of all, would be an equation. We're not talking inequalities here. We're talking equations in which we have two or more. We're only going to deal with two. You won't have anything more than two, but two or more equations containing two or more variables. A solution of a system of equations would be the values that make them true. It's very important that you understand the transitive property. If A is equal to B and C is equal to B, then A is equal to C. I need you to think about that because the transitive property is used in solving system of equations. So I'm not going to go through every single step in these systems because I don't think that would probably help you. You're going to have to do this on your own. But a couple of things I want to point out. First of all, this is a system of equations. There are two equations. In a system, there could be more than two. But in this case, we have two equations in which we have two different variables in each equation. As you can see, we have the variable y alone in each of those. So we are doing a two-column solution. Over here in your cheat sheet, it says if you have a variable alone in either of the two equations, you are only going to need two columns. If you don't have a variable alone, you're going to see one of those in a second, you must create three columns. So what we did, really briefly, what we did is we took one of our variables, y equals 2x plus 1, and we plugged it in for y. And this is how we wrote it. 2x plus 1 equals 4x. And then we went ahead and solved because now we just have the variable x. We solve for x. Once we solve for x, right here, we plugged it back into one of our equations and got y. Sliding on down. Do we have variables alone here on number 5? What happened though? Remember this guy? When we solved, we have 0 does not equal 13, or we had 0 is equal to 13, which isn't equal, and therefore we have a no solution. So if that happens, you're done. There's nothing else to do. I would probably double check to make sure you didn't make an error somewhere. Number 6, do we have any of our x or y's alone? No. So our first step is to get a variable alone. So we decided we wanted to use 5x plus y equals -7, and we wanted to get the y alone. So what we've done all year is we solve to get the y by itself. Once we got y alone, then we can plug in -5x minus 7, because that's what y equals, into our opposite equation, into that one right there. So -5x minus 7, we plugged in for this equation, x minus 3, and then the y becomes the -5x minus 7. Okay, so this is where we plugged in -5x minus 7. We solved for x, we plugged x back into one of the equations, got y, and that became a gigantic, I think this one was like 18 or 19 steps. I promise you I will not give you one with fraction answers on the test. Okay. Number 7 was the one we just did this morning with Eleanor. Same concept, we had to get the variable alone. We got the variable alone, or a variable alone. Does it matter which one?
No.
Does it matter if you get x alone or y alone? We chose to use 6x minus 1 equals 14, but we could have actually gotten y alone and used that as well. And then I'm not going to talk about this one, I would just make sure you understood how we wrote our own system with number 8 on a word problem. The most challenging, difficult part, once you understand systems of equations, is probably going to be writing your own system. Questions before I stop, or anything you want me to add to the video?